All right, so buckle up because we are diving headfirst into the world of AI today.
It's not your everyday kind of Nobel Prize in physics, is it?
Definitely not.
When you think about physics, you think, black holes or atoms smashing together,
All right, exactly.
not necessarily something that's, quietly powering
Yeah.
like the smartphones in our pockets.
Yeah, this year's winners are definitely shaking things up a little bit.
Yeah.
So that's what we're talking about today, John J. Hopfield.
And Geoffrey Hinton.
Two scientists who were already making waves back when AI felt more like a movie plot than reality.
Back in the 80s.
Yeah, exactly, like way back when.
Because they were laying the groundwork for so much of what we're seeing today.
So let's break it down.
Okay.
Who are these guys and what exactly did they do?
So you've got Hopfield. He's a professor at Princeton.
Okay.
And then Hinton is at the University of Toronto.
Big names.
Big names. And what they did that was so important was that they were pioneers in this field called artificial neural networks.
Okay, so before you go any further, artificial neural networks, that sounds complicated.
It does. It sounds very, very complicated.
Can you give us like the non-technical explanation? Like I'm 5 years old.
Okay, you're 5 years old. You want to teach a computer to recognize a cat, right?
Right.
So instead of saying, okay, look for pointy ears, look for whiskers.
Right, right.
You create a network that learns by analyzing tons and tons of cat pictures.
Oh, interesting.
And it figures out the patterns on its own, kind of like we do.
So instead of programming a computer with a hard and fast rule, it's more a system that's learning from experience.
Exactly.
That's so cool.
So it's mimicking the way that our brains learn.
That's wild.
Which is why they call it artificial neural networks.
So were both Hopfield and Hinton working on these cat identifying networks together back in the day? Or is it more nuanced than that?
It's way more nuanced.
Okay.
They were both working on different aspects of it.
Okay.
So Hopfield, he developed something called the Hopfield network.
Okay.
Very simple, named after himself.
Well, of course, why not?
But what this network was all about was how our brains store and recall memories.
Oh, interesting. So is it like the brain's own Google search, digging up old memories on demand?
You could kind of say that, yeah.
Hmm.
It's like trying to replicate that process in a computer.
Wow.
But what's really cool is that
Yeah.
he drew inspiration from, get this, the world of physics to create this.
Okay, now you've got to explain that one because I don't see the connection there.
Okay, so his network uses this idea of atomic spins
Okay.
to mimic how our brains hold on to information.
Wait, slow down, slow down.
Okay.
So you're telling me that like the way these tiny little particles spin around
Yeah.
influences how a computer remembers something?
It's kind of like that, yeah.
That's wild.
It's this crazy intersection of like the microscopic world
Yeah,
and then the way that we, store our memories and our thoughts.
Wow.
Pretty wild.
That's incredible.
And it's this connection that makes their work
yeah.
worthy of a Nobel Prize in physics because it shows how deeply connected these two fields actually are.
That makes sense.
Yeah.
So that's Hopfield's contribution, taking cues from the tiniest particles to unlock artificial memory.
Exactly.
What about Hinton? What did he do?
Hinton took things to another level.
Okay.
He did.
Okay.
With his invention called the Boltzmann machine.
The what?
The Boltzmann machine.
Boltzmann machine? Okay.
So picture this,
Right.
right? A network that's incredibly good at spotting patterns, even really complex ones,
Okay.
that your normal computer program would just be like, whoa.
Right, like it wouldn't even know where to begin.
Yeah, it would have no idea.
Okay.
But this thing could.
Okay.
It was really good at that.
So like if Hopfield's network is like remembering where you put your keys,
Right?
Hinton's network is more like finding a specific face in a stadium full of people?
Yes, like that. Yeah,
Okay.
like that, but even more complex probably.
Wow.
So think about the jump from like basic memory
Right.
to being able to analyze.
For complex patterns,
That's incredible.
which is a big deal.
Yeah.
So his Boltzmann machine, a major step toward the powerful image recognition we have today,
Wow.
like that we just take for granted.
It's true. It's true.
Right.
Yeah.
Facial recognition, all that stuff.
Yeah, that's insane.
That comes from that.
Okay, so now it's all starting to click.
Yeah.
So these networks from way back when,
Yeah.
like we're talking the 80s,
yeah.
they're like the great-great-great-grandparents of the AI that we use today.
Pretty much. Yeah.
Things like, facial recognition,
Yeah.
the recommendations I get, when I'm online shopping,
Yeah.
that are eerily accurate.
Yes. Yes, it's all based on that.
It always goes back to that.
They may not have been as advanced or as sophisticated
Right.
as what we have now,
Sure.
but it all had to start somewhere, right?
It's true. They sparked a revolution without even knowing the full extent of what they were starting.
Right?
It really shows how groundbreaking scientific discoveries can echo through time.
It's really cool.
It is really cool.
But I can't help but wonder if Hopfield and Hinton could see where we are now with AI, would they be like totally stoked?
That's it.
Or would they be a little bit terrified?
That is a good question. And it's funny you should ask that because Hinton himself has actually expressed some concerns.
Oh, really?
Yeah.
Okay, tell me more about those concerns.
Well, one of the things that worry Hinton
Okay.
is how good AI is getting at creating things.
Okay.
Like we're talking about, AI-generated music
Right.
that could be mistaken for a human composer's work
Oh, wow.
or AI-written articles that are, pretty much indistinguishable
Right.
from something a seasoned journalist would write.
I've seen that, and it really does make you wonder, like, where's the line?
Yeah.
Is it even impossible to tell what's human-made and what's not anymore?
Yeah.
It's kind of creepy.
It's a little creepy, and it's not even just about, like, playing a guessing game.
Right?
Like, is this real or not?
Right. It's bigger than that.
It brings up all these questions about authenticity and, like, ownership.
Right. Like, if you can't tell the difference between an article written by, a real person and one that's just generated by a computer,
Right.
what does that do to, our trust in information?
Exactly. Like, what are we supposed to believe?
It's wild.
Yeah.
It's exciting and terrifying all at the same time.
It really is, yeah.
So we've got that whole issue, and then we've got this whole other side of AI
Right.
that I know that Hinton has spoken about, which is its use in warfare.
Yes,
Yep,
yes.
sure.
A whole other can of worms.
We're already seeing it, right? Like AI is being used in military drones, other autonomous weapon systems.
Yeah. And it feels like we're living in a sci-fi movie.
It really does.
But it's real.
It's our reality.
It is. It is.
And then you start thinking about, okay, AI making life or death decisions on a
Right.
battlefield.
Right.
Like, who's accountable when something goes wrong?
Right. Who do you blame?
The programmer, the person who deployed the technology.
It's
I don't know. It's
a tough one.
a really, really tough one.
It is.
And there's no easy answers to these questions, but we have to ask them.
We have to because it's here. The technology is here.
Yeah, that's the thing.
It's not going anywhere.
It's here.
So we've got to figure it out.
We do. We got to figure it out because I feel like on the one hand, we have this technology that has the potential to just revolutionize every aspect of our lives.
Right.
And on the other hand, we're grappling with these huge ethical questions that almost feel too big to even wrap our heads around.
Right. It's like that classic,
Yeah.
like double-edged sword thing.
Yeah, and it makes you realize,
Mhm.
like, winning this Nobel Prize,
Right.
it's not just about,
Right.
recognizing a scientific achievement. It's about acknowledging the weight of it.
Exactly. The responsibility that comes with this kind of discovery.
Yeah, I like to think that, the Nobel Committee is kind of putting it out there,
Putting it on us.
saying, hey, look what these brilliant minds have created.
Right.
Let's maybe make sure we're using this power wisely.
Yeah, it's like a call to action
It really is.
for all of us, like scientists, policymakers,
Yeah.
everyone. We got to figure this out.
Yeah, we got to think critically about this stuff. This
Yeah.
isn't just some futuristic fantasy anymore,
Right. This is
our present and our future, whether we're ready for it or not.
exactly. So what are we going to do about
So
it?
where do we even go from here? It feels like this whole conversation about AI is bigger than all of us,
It really is. And to be honest with you, there's no easy answer. There's no one solution.
Right.
But I think one of the most important things we can do is try to approach AI with a healthy balance of curiosity and caution.
So get excited about the possibilities, but don't just blindly charge ahead without thinking about the consequences.
Exactly. Exactly. We need to embrace that potential, but also, be realistic about its limitations.
Yeah,
Because there are definitely downsides. We can't ignore that.
it's true. Easier said than done, though, right? Because like we said, AI, it's already so woven into our everyday lives.
It's everywhere.
Yeah, so how do we even begin to steer something this big and this powerful in the right direction?
It's a huge challenge, but I think it starts with knowledge, right?
Yep.
The more people understand how this stuff actually works,
Right.
what it can do, what it can't do,
Yeah.
the better equipped we'll be to make those decisions about how we use it.
So no more burying our heads in the sand. We can't just ignore it and hope for the best.
Exactly. We got to engage with it.
We do.
And that means asking those really tough questions like, what are the ethical boundaries here?
Right.
How do we use it for good?
Right. Right.
How do we deal with the impact it might have on jobs, the economy, all that stuff?
It is a lot.
It is, but we have to talk about it.
We do. It's a lot to think about, but it's also kind of empowering in a way because, hearing about these pioneers like Hopfield and Hinton, it reminds us that, we get a say in how we shape the future of technology.
Yeah.
It's not all predetermined.
Right.
Like, we get to make choices about how this stuff goes.
And I think that's what's so important about their story.
Right.
Because it's not just a history lesson.
Yeah.
It's really a challenge for all of us to decide what kind of future we want to create with this technology.
It is. It really is. So to our listeners out there, think about that. The future of AI, it's still being written.
Yeah.
And your choices, your voice, they matter.
They're a part of that story.
Exactly. So what role are you going to play? That's all the time we have for today's deep dive, but from both of us.
Yeah, thanks for listening.